Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, which is also connected to two probes for oscilloscope. Serial cable for data communication, Raspberry Pi camera for alternative view except for this camera and another camera, and somewhat hidden is a network cable for VNC, virtual network computing, and very visible is this band cable which leads to this breadboard with electronics, and currently I am focusing on this part of the circuit. Well, this circuit, which is not part of the other circuits, controlled by SPI, serial peripheral interface, and that is communicating with this analog to digital converter for a light dependent resistor from fischertechnik. This is also a light dependent resistor, an NTC, negative temperature coefficient resistor, and that and all the components are connected to ground and power. And as you could see, the Raspberry Pi camera is supported by fischertechnik as well. On the fischertechnik stand, that is. It's not made by fischertechnik. The idea is that I read the values from the components and that everything is shown on screen, but also captured by scientific language Octave into a vector, and that I can get anything going, that I can read everything. And that was a problem last time with the data capturing, or data processing. Since here is no real thing to be seen, I can start things, of course, but if you can't see anything like an LED, like now you can't see anything, and I can see things on screen. So let's go on screen. And then you can see here the yet another camera, then the oscilloscope, obviously, transmitting things over serial line RS232. This is transmit, this is receive, sending things over via minicom, and I should actually name this tab minicom to make sure that everything is being dealt with. This is on screen. This is for the Raspberry Pi camera, which you can see right here. Nothing much to see. Things do work. And I had the intention to also use the Pi scope, which is an on-screen oscilloscope, but it suddenly showed an error. No data. So too bad, but yeah, things happen. So now it works. Last time it didn't work, and I noticed a wire being not quite as it should. So I removed the wire, being this one, and now I have all nice values. So what is the point? The point is that with this one working, and let me go here. Now you can see clearly that this is LDR2, because if you look at that value, it's now 49 something. I cover it up and it goes very high. Then the other one, which is right here, I cover it up and it gets very low, or should get quite low. Now it gets even higher. NTC value, not really much, but anyway, it works. Yeah, pin 7 is not connected anymore. So this LED and this LED are not showing anything. I can connect it again, but for now it has to be. Then Octave. The point here is that I want to get all data. This is how I convert the bytes to ASCII, readable, because bytes are numbers and numbers can be converted into characters, and that is what you can see. Then I want everything in here, and for some reason the ASCII is converted back to bytes, and then I want things back into it. That didn't work. This does work, by the way, kind of. I have to change data 2, by the way, to make it a 12 byte declared. Then everything will be alright. And then I want things being taken out, like I see right here and right here, which is which. And the problem is that resistor value is longer than the other ones. The lines are longer, and if I want to use indexing, they have to be equal as long, but I can of course shorten this or make this longer, and I think the last one is better. It's about the number of bytes, and this is 1 byte, and this is 1 byte, and this is 1 byte. So let's see how this works out. In here, that is. Right. Right, so let's get all this in Python the same, so that all bytes are the same. And then I'm talking about some column. I do not know which it is. Alright, settings. I want to see columns, which I do not. Alright, never mind. So this is counting then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think this is better, and Right, if this is correct, then nice bytes are sent. So let's quit this one, save, go again, and now all should be lined out. If these are indeed single bytes, which I do think, then now the indexing can be quite correct. So let's go to Octave. Then I do have to end this session. Right, I have to reload it. This one. Run. Yeah, I'm going to change this a bit. Why is X not working? That is strange. Alright, I have to cancel. Odd. Anyway, it gets data. I will not convert it. Because I am converting it here. And here I will say data 2 is zeros 12 1. This I will not I won't have to see. Question is, I get it in here and I will get it in here as well. Strange thing is, here's something as well, and that is unnecessary. So here I put all data in this one, and then I better have here data 2 to avoid confusion, and then it should be better. Let's run it. Uh-oh. Line 22, column 40. So what's happening here then? So this means that I have to use this. Yeah, apparently. Okay. Alright, so let's quit this and look at data. How many bytes? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it's 12 bytes. Still kind of rubbish. So how many bytes are here? This is 5, 8, 9, 14, 15, 16. 16. That's a different story. So I have to change this actually to 16. Right, I have added here 16 parts of data. Oh, by the way, I have to add 16 here as well. And this is better. So now things, no, because here I have to go 16 as well. Right, now it might work. Yeah, it might have worked. This is garbage. So why is it garbage? What is sent anyway? Oh, right, of course. Here I am sending things as well. So this has to be 16 just as well. That is a good one. So how can I get that nicely? Four, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, 16. And this is 4, 5, 6. This should be 16. This is then 6 again. And then it proves hard to count. And last but not least, alright, let's try again. So quit this, run. Now things are being sent, and I want to know why this is not working. That is very strange. The X is not working. I can only do Ctrl C, which I do not want to use. Very strange. Anyway, go. And still garbage. Because if you look here, I have resistor value, which is well, actually good here, but the value, where is my value? Resistor value, nothing. And then suddenly LDR value, nothing. So things aren't quite correct. Alright, let's go to minicom. Oh wait, minicom is still running. That may help. Once again. Yeah. Better, although just slightly. So, okay. Now I want to see the content of data 2, because right. That is not what I expect. So it does get its very latest of the data being sent, but that can be anything, because you're picking up right in the you may be picking up somewhere right in the middle of it. And another thing is, of course, what if I just do it like this? Then I see what something is. Is this the same? Nope, it's not. This is the same. So it's better to have dots than you know what you're doing and what you're watching at. That's better. Quit and go. And of course, this goes only for this one. Yeah. So anything that is nicely aligned here may not be aligned in here due to whatever. So it's not that simple. And if I now ask for content of data 2, I get the same, well, not really usable stuff. So I have to expand this vector has to be expanded quite a bit. Well, this works nicely. Right. You can see the values, not really this one. This is LDR1. Doesn't really change, does it? Yeah, it does change a bit. This changes, this one changes a lot. When covered, it has the exact opposite effect as the other one. And it always did. Although now the wiring may be a bit off. Not to say completely gone. But anyway, it's nice. And another thing is, of course, that I can use a data log, because here things may be going by to never be recovered, but that doesn't go for this. So I have created a data log file, how surprising, and writing here to the data log file. So let's quit here, save, and see how things work out then. Oh, right. I have to write things to string. And then I quit to see what the data log consists. And that is right now only this one. Really? So that doesn't matter then. So I go down here and I say actually the same thing. Copying. Paste. String to which is actually an LDR value. And then write new line. That will be better. Go and check and see. 2 iterations already done, and you have a nice thing. So basically this enables me to see how things compare with Octave, which would be a very nice thing to do. So copy and paste. This is LDR2 value and LDR value 2. This is NTC value. Copy, paste. Be careful what you copy and paste. Oh, this is going wrong. And that would be it. So, and no, go. I have made an error in here and nowhere in here. Oh, right. Writing. Yeah, the 2 and the W value are very close together, so this needs to be a 2 instead of a W. Correct. Go. And then of course it's more fun if you cover an LDR, so you have multiple values, and in minicom everything is nicely aligned. By all means, if you want to select the right place, and here you have everything that you like. And here things are totally different. This is, yeah, compare. So how to fix this one? Good question. Alright, and that's it for now. So, got some work done, working better, but not as nicely as could. Not that much attention for oscilloscope, which I had on the wrong time scale, but it does work. So, what's next? I don't know yet. I will come up with something. Thanks for watching. Anyway, if you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. Much appreciated. You can also follow me via Instagram and Twitter. Please show your appreciation by making a donation via either PayPal or Wired. You can also choose to become a patron and may have your name mentioned. This will be continued. Have a nice day. Oh, by the way, you can find everything under this video, including the URL of my website with much more information, and social media names and more info. Like I said, have a nice day. and bye bye.